Hey guys, welcome to Unit 4. Today we're going to get started with Lesson 1, Parametric Equations. I want you to pause the video and read all this and then we will analyze it. Welcome to Unit 4. Our lesson today is Parametric Equations. So I want you to pause the video and read the part, this whole part, and then we'll analyze it. Okay, so there are a few things that it's talking about. It's talking about imagining hitting a golf ball and watching its flight path until it lands. So if I was to sketch it, it would be something like this, right? Let's say I hit a golf ball and this is kind of a path it's taking, right? So we can write rectangular equations that model the height of the ball as a function of the distance traveled. We are interested in analyzing each of these separately as a function of time. So to do this, we would need two separate equations, one to model the height of the ball, call it y, as a function of time t, and another to model the distance the ball travels, call it x, as a function of time. This is the idea behind parametric equations. The saying is, here this is the height, right? Let's say my y-axis is the height and I'm going to write that equation as a function of time, and on the x-axis I'm doing distance, that is also a function of time. Because if I want to find out, like this point, if I was to talk in rectangular, that's how much distance I've traveled, so it's this distance and that's the height, right? But if I want to know at t equals, let's say 3 seconds, where is my ball? So that is why my time becomes the independent variable and both height and distance are the dependent variables. So in general, parametric equations are a pair of equations that involve a third independent variable, which usually represents time. Both x and y are now dependent variables. This is the reason why they're both dependent, because they both, your height and your distance, are written as a function of time. So let's get started with example 1. It says a particle moves through the xy plane. Its position given in feet at time t seconds is modeled by the equation below. Without a calculator, make a table and sketch the curve the particle flows, indicating its direction. So you want to indicate the direction of the flow of the particle, and also eliminate the parameter. The parameter we said is what? T. So we want to eliminate the t, or we can say get rid of t. So there are two things we are doing. First, we have to make up a table and sketch it. How do we do that? Since there are three variables involved, we're going to make a t chart, but we're going to have three columns to it. The first one is going to be t, and then x and y, because these are the three variables. Now, how do I get started, right? So this is what we look at. T is between -2 and it's greater than -2 and less than 3. So those are the values I'm going to get started with. So -2, 1, 0, 1, 2, 3. So these are my t values. I know my t values and I'm going to substitute them into each of the equations. That's my equation 1. That's my equation 2, and find my corresponding x and y values. So pause the video and maybe you can fill it up and then match with mine. So I hope you got these x and y values once you substitute in case you're still confused how I got these values is, so I took my first t value, which was -2. So I did -2. I substituted into the x equation. So -2 square minus 4, which is 4 minus 4, which is 0. That's how I got 0 here. Similarly, I did -1. -1 square minus 4 is -3, and so on. For my y values, I went to my y equation and I substituted for t from -2 to 3. So I started with -2 divided by 2 is -1. So that's how I got my values. Now once you have the values, what you're going to do is, how are you going to graph it? Since we're doing it in the rectangular coordinate, we are going to be just plotting the x and y. So when x is 0, y is -1. So that's your point. And -3 1/2, -1/2, 4, negative 4, 0, negative 3, positive half, 0, 1, and 5, 1, 2, 3, 4, 5, 5, and 3 halves, which is 1.5, right? And look at these are both less than and equal to, so this will be a filled circle, and I'm gonna connect these points, right? It's very important to write the direction because I started at 0, negative 1, so the particle is moving in this direction, right? So direction is very important, and it also in the question here said the particle moves through the xy plane, right, and indicate its direction. So if you don't indicate the direction, you do end up losing points. So please make sure you indicate the direction. So this is how you graph these two equations. Now part 2, which it said get rid of the parameter. How do you do that? So you want to take the first equation or the second equation, whatever one is easier to work with, and solve for t. So I'm going to take the second one because it's so much easier. So I'm going to have y equals, or 2y equals t, right? Now I'm going to take this value of t and substitute it in the first equation. So x is equal to, in place of t, I'm going to write 2y square minus 4 and simplify it and have it written for y. So it'll be x equals 4y square minus 4, right? So it'll be x plus 4 equals y square, x plus 4 over 4, right? And then you take the square root, so it'll be y equals plus and minus square root of x plus 4 over 4. So that's how you eliminate the parameter, meaning you write the equation in terms of x and y. So let's write that down. Get rid of t, write the equation in terms of x and y. That's basically it. So you're just getting rid of the parameter. Okay, let's try example 2. Again, if you want to pause the video and try it on your own, please feel free to do it. So again, we're doing the same thing. First, we're going to graph it and then get rid of the parameter. I'm going to make up my t-chart with my 3 columns in it, t, x, and y. The domain of t is what? It's saying t is greater than or equal to 0. So you want to be a little careful here when you're picking the values of t, because remember there is a square root in the denominator, so you don't want decimals, right? So I'm going to pick any numbers that are greater than 0. So I'm going to start with 0. So what do I get? If I substitute 0 in here, I get 1 for x, and for y I get 0, right? Now if I substitute 2 for the x equation, I do end up with rad 2 in the denominator, and it wouldn't really help me. So I want to pick values of t that are greater than 0 that will make it a perfect square. So can I pick 3? So 3 plus 1 is what? 4. So this would be what? 1 over square root of 4 is 2. So it's going to be 1/2. And this would be what? 3 over 4. And then what's the next perfect square? 9. So pick one value number less than 9. 8. 8 plus 1 is 9. Square root of 9 is 3. So 1/3. And similarly here I will get 8 over 9. Right, you can keep going on. The next number, if I was to pick, I would pick what? 15 for t, right? And I will get what? 1 over 4. Do you see that? And this would be what? 15 over 16. And you can keep going on from there, right? So let's graph it now. So when you're graphing, you're going to make sure that you are using your x and y points. So 1, 0. I'm going to actually go here. This is my 1. Let's make this 1. I'm scaling it, and if I want to scale the y-axis also, so this is going to be 1. So this is 1, 0, right? Then 3 and 1/2 and 3/4. 1/2 is right here, 3/4 is right here, right? And then 1/3 and 1/9, 8/9, which is less than 1. Do you agree? Then 1/4 and 15/16, Look at this. If I was to pick the next number, it will be 24, which would be 1/5, and this would be what? 24 over 25. Do you see all these numbers, all your x and y values will be less than 1. So what happens is when I graph it, it's going to be this. It's in this direction. I didn't get a really nice graph. I'm going to try again. My points are like a little messy. And this is going to be an open circle. Why? Because all these values are going to get very close to 1, but will never touch it. And you can try by substituting a lot of them. And this is the direction it's going in. You started at 1, 0, and it's going in that direction. So make sure you do have your arrows there. Okay, so now let's eliminate the parameter. So I am going to take one of these equations. So I'm going to take the first one, square both sides. I get x squared equals 1 over t plus 1. Let's cross multiply. So I get t plus 1 equals 1 over x squared, right? And now I want to subtract 1, so I get t equals 1 over x squared minus 1. So I got that t here. Now I want to substitute that t into this equation and get rid of the parameter, right? Oops, I'm writing y, not t. Y is equal to, so I have 1 over x squared minus 1 all over 1 over x squared minus 1 plus 1. The ones cancel out here. I'm just going to take it here. So this would be what? 1 minus x squared over x squared, y is equal to over 1 over x squared. If you do the keep change flip, the x squares cancel out, and what are you left with? Y equals 1 minus x squared. So that is your equation. So now example number 3. Do the same for x equals 2. We're given the two functions, and your domain is between 0 and 2 pi. So what do you think you're going to pick? What t values are you going to pick? T, x, y. Let's change colors. So I'm going to start at 0, and then I'm going to go by the increments of what? Pi over 2? 0, pi over 2, because I have cosine and sine. So anytime you're working with trig functions, just be careful what values. That is where you need to put a little thought into what t values should I put in, that it's easier for me to graph and I get whole, like integer answers rather than like crazy decimals or irrational numbers. Pi, 3 pi over 2, and 2 pi. Right? Let's pick like a little darker color. So now substitute in here and pause the video and see if you get those. So I'm going to do the first one. So it's what? 2 plus 3 cosine of 0 is 1. So 2 plus 3 is 5. I'm just going to do all the values for the x. Then I'm going to 2 plus 3 times 0, which is 0. So it's going to be just 2. Then 2 plus 3 times cosine of -1, which is cosine of pi is -1. So -3, which is -1. And then 2 plus cosine of 3 pi over 2 is 0. So that would be just 2 and 5, right? They start repeating after a certain while. So similarly, I'm going to do this thing for sine. So -1 plus 2 sine of 0 is 0. So this is going to be just -1. It's -1 plus that. This is 0. So -1 plus 2 times sine of 0. Then I have what? -1 plus sine of pi over 2 is 1. So -1 plus 2 is just 1. Then -1 plus 2 times 0, which is again -1. -1 plus 2 times -1, because sine of 3 pi over 2 is -1, right? So that's -3 and then -1, right? I hope you got the gist of it. I'm going to erase these. Okay. So now what do? I need to graph them. So let's graph them. So it's 5, -1. I'm going to take green. 1, 2, 3, 4, 5, -1. Oops. 5, -1. Then you have 2, 1, 1, 2, and 1. Then I have negative 1, negative 1, negative 1, negative 1. I have 2, negative 3, 1, 2, 3, negative 3, and 5, negative 1. It's repeating now. So what kind of shape did I get? I got an ellipse, right? And what was the direction? It went in this direction. I started at this point. You must have your arrows, right? With the center, what's the center here? This looks like an ellipse, right? It's not a circle, it's more of an ellipse with a center of 2, negative 1. So now let's see, when I erase the parameter, shouldn't I get my equation also of an ellipse? So here, if I look at these two equations, I'm going to solve for cosine t. So what do I get? X plus, sorry, minus 2, x minus 2, x minus 2, 3 cosine t is equal to x minus 2. So can I say cosine t is equal to x minus 2 over 3? Right? Similarly, I'm going to find my sine t. So if we do that, sine t is equal to what? Y plus 1 over 2, right? So now, whenever you're dealing with sine and cosine in here, you want to remember of this identity, because how do I solve it? I really can't substitute. I can't solve for t, so what do? I'm just going to change color actually. So you know of this identity, sine squared t plus cosine squared t is equal to what? 1. So if I square both sides, I'm going to square this and I'm going to square this. What do I get? I get, and I'm going to substitute in here for sine square t, I'm going to substitute y plus 1 square over 4 plus, if I square the cosine, I get what? X minus 2 square over 9, which is equal to 1. I'm going to write my x term first because I usually write that. So plus y plus 1 square over 9 equals 1. And that's your equation of the ellipse, right? And with the center, if you were to check, look at this. The center is what? It's always the opposite, 2, negative 1, right? So that's how you would do any sine cosine equations. Just square them and you'll get your equation of the ellipse or circle, depending on what your denominators are. So in example number 3, we made use of the trigonometric identity. What identity did we use? We used the Pythagorean identity, which is sine square x plus cosine square x equals 1 to sketch an ellipse. Which trigonometric identity would you use to obtain a graph of a hyperbola? Do you remember what a hyperbola looks like? Oops, I couldn't spell it. This is what a hyperbola looks like. When you would have something either like, you know, sideways, that's one way, or these ones. So what is that, right? So think about it and share your answers with me in class, or just email me. For the remaining lesson, I want you to finish all the practice problems. There are 5 of those, and there's also, I have attached another sheet for homework, so please do those and upload them onto Canvas. If you have any questions, feel free to ask me.